and you should see something along these lines. So don't be confused or overwhelmed by all of the different things that are going on. I will explain to you everything that's happening here in a second as well. Hello everyone, and thank you so much for joining me here for another YouTube video on my channel. I know it has been a while. As you can see, we're at a new space, and as part of moving homes, I lost internet for 2 weeks. I didn't have a proper connection. I felt very much cut off from you, from the rest of the world. And as you can see, this is quite a large living area where everything kind of happens. You can see maybe some dog toys on the floor, some laundry in the background. So as this space evolves, there will be changes. There is an echo right now, probably in the sound. I apologize for that. Do let me know in the description if you have any ideas on suggestions on things I can do that are stylish and improve the sound of the room. I would love to hear from you if you have any ideas. Anyway, this video is really exciting. It's about the Trivy Operator. The Trivy Operator is a Kubernetes operator. It follows Kubernetes best practices. It is built based on Trivy, the all-in-one cloud-native open-source security scanner. So as you might know, I work for ArgoCD as their open-source developer advocate. And one of our main tools is Trivy. Trivy is a CLI tool that allows you to do security scanning of your container images, your infrastructure as code files, of our configuration files. It allows you to generate SBOMs and much, much more. And as part of the features, you can do Kubernetes cluster scanning for security issues, for exposed secrets, for misconfigurations, for infrastructure assessment, compliance scans, everything, also right through the CLI. So here we are in the Trivy repository on GitHub. It's a completely open source tool. You don't sign up, you don't send us any data. There's nothing that we can do to know that you even exist and you're using our tool, unless you star our GitHub repository. So please do give us a star if you like Trivy. Anyway, so installation. There are lots of different installation options for Trivy. Now, this is for the Trivy CLI. We can then go ahead and check out the documentation. Within the documentation, you will find here under targets, the Kubernetes target. So this is a scan target. So basically, Trivy is divided in the types of scanner: vulnerability scanner, misconfiguration scanner, secret scanner, and so on. And with that, you can perform different types of scans. For example, you can perform a Kubernetes cluster scan with Trivy. To perform a scan of your Kubernetes cluster with the Trivy CLI, you first have to have Trivy installed. Check that you are on the latest version. We have new releases on a monthly basis. And then you can go ahead and scan your Kubernetes cluster. Now, do make sure that you're connected to a Kubernetes cluster. In this case, I'm using a local kind cluster and scan that for security issues. You need to either be connected to a kubeconfig file or provide the kubeconfig file path to the Trivy CLI command. And then you can go ahead and perform a cluster scan. Now, in this case, I'm going to scan the cluster and provide a summary report of all of the security issues across my cluster. You can also scan specific namespaces or specific deployments and other resources. In particular, you can also get the detailed report. You can save that report to a local file and do much, much more with the Trivy CLI. It's all provided in the documentation of the different options that you have. Now, when would you use the Trivy CLI to perform in-cluster scans? We have a comprehensive blog post on the ArgoCD blog that details when you use the Trivy Operator versus when you use the Trivy CLI. Generally, to use the Trivy CLI, you need to have access, obviously, to the Kubernetes cluster, as in this case, so I can perform the different scans. Similarly, it doesn't make sense for me to perform the scan if I'm not then authorized to make changes directly to the cluster. So this is different than, for example, if you use the Trivy CLI in your pipelines to run a security check of your infrastructure, because then in your pipelines you can share with other people. Now, for the CLI, to use the Kubernetes commands, you would really want to be the one, the cluster admin, the SRE, who can then make changes. So if you want to have continuous testing of your different resources within your cluster, and generate reports of your different resources whenever your resources change, whenever they are modified, whenever new resources are deployed on a continuous basis. That's when you want to use the Trivy Operator. Now, the Trivy Operator works like any other Kubernetes operator in that it lives inside of your Kubernetes cluster and monitors your resources. It runs a continuous reconciliation loop that basically tracks all of the resources within your cluster. There are several different installation options. So you can, for example, install the raw manifest through kubectl, and you can use the Helm chart. Now, where does the Helm chart live? The Helm chart lives inside of the main repository for the Trivy Operator. You can find here the deploy directory, and within here you can find the Helm chart, as well as the different options how you can modify the Helm chart. As always, if you prefer the written version of my video tutorials, the link to the blog post published on my blog is linked below. You can find here all of the details and much more of what I'm sharing in this video. So do check that out if you want to have the written version, as well as the detailed commands that I'm using within this video. Some of the benefits of using the Trivy Operator is that since it's a Kubernetes native installation within your Kubernetes cluster, it makes it much easier to integrate the Trivy Operator with your other resources. So with your other applications, for example. Check out, for example, our Grafana dashboard and the installation of the Trivy Operator in combination with Prometheus and Grafana, and then you can generate a dashboard in Grafana that details all of your security issues across your infrastructure. You can also set up alerts directly through Grafana or through Prometheus, through Alert Manager in Prometheus. So we're going to go ahead and install the Trivy Operator using the Helm chart commands. First, we need to add the Aqua repository, the Helm chart repository where all of our Helm charts live, to the charts that we have locally for Helm. So make sure you have Helm installed, Helm version, and then we can go ahead and we can add the Aqua repository to our Helm chart repositories. Now, in this case, I'm already having the registry locally, or like a version of it, so I can run Helm repo update to retrieve all of the newest changes of my different Helm charts. And then once I have that, I can go ahead and I can install the Trivy Operator to my cluster. Now, in this case, if I'm opening my cluster, I don't have anything installed. I just have the default Kubernetes components. I can also look at the different namespaces. As you can see, those are my different namespaces. You might have other namespaces depending on where you're installing the operator. Now, if you're installing the operator, especially on a cluster that's not just yours, right? Or a cluster that you want to keep for a longer period of time, that's not just there for you to play around with, what you want to make sure is you create a new namespace. So generally, when you follow these commands, for example, when we install the Trivy Operator through the Aqua Helm chart repository, in this case, we can specify that we want to have a namespace Trivy system and we want to create this namespace upon installing the operator. Now, similarly, when you clone the GitHub repository and you install the Helm chart from the repository directly, so if you use this command, you would have to clone this repository and then be here in the root repository, and then you would deploy the Helm chart by having the repository locally. Now, in our case, we want to use the Helm chart registry, and we want to create a new namespace. Now, if you don't set namespace and create namespace in your commands, then I would suggest you to create a new namespace first. You could create a new namespace by saying kubectl create namespace, and then you can create a test namespace. Now, we are not using this test namespace. We are using this command from Trivy, from the Trivy Operator documentation, and it basically sets up the Trivy Operator. It creates the namespace, and it sets this value here of trivy.ignoreUnfixed equals true. I will explain to you in a second of what that command actually does. But let's first run this command. As you can see, here's also the version, which is really important that it uses the latest version or a specific version of the Trivy Operator image. We will go ahead and we'll install the Trivy Operator to our Kubernetes cluster. You should see this kind of output that the Trivy Operator has been deployed. Now, once this has been deployed, we can check out our Trivy system namespace. So kubectl get all and namespace Trivy system. And you should see something along these lines. So don't be confused or overwhelmed by all of the different things that are going on. I will explain to you everything that's happening here in a second as well. First, let's go back and share with you what the trivy.ignore_unfixed equals true means. Where is this value coming from? So going back to the Trivy Operator Helm chart, we can see here that every Helm chart has a values.yaml file, right? So in this values.yaml file, we specify lots and lots of different flags, different components, right? And within here, we also specify the image, the container image that's supposed to be used within the operator. And then we specify some values, for example, for Prometheus, and we specify some specific values for Trivy Operator. And if we scroll a bit further, we can see here Trivy. Now this section kind of configures how Trivy is supposed to run. So how Trivy is, for example, supposed to do vulnerability scans within your cluster. And within here, we should find a value saying ignore unfixed. Here, ignore unfixed. And right now, by default, is set to false, meaning that Trivy, when Trivy performs a vulnerability scan, it will report both the vulnerability issues that have a fix available and those that don't have a fix available yet. So in our case, we want to make sure that we only see the values that have a fix available. We don't care about the vulnerabilities that don't have a fix available. So we want to set this value to true. How do we set this value to true? We have to say Trivy because it's within the Trivy section. Trivy.ignore unfixed equals true. And this is what we have done within here. Sorry about that. Within this command, we have set as in like set the value Trivy.ignore unfixed equals true. That's how we can modify, customize the Helm chart. If you're completely new to Helm, I highly suggest you to check out my other videos on Helm. They are linked up there right now, as well as down there in the description. So do check those out. They are not completely out of date. I have recorded them a long time ago. If you're curious, I can make new videos on Helm charts. But generally, what I'm saying in this video still holds true. The videos are based on the Helm book that the core maintainers, the people who created Helm have written. I think 2 of them have written a book, and those videos are based on that book. Anyway, so let's check out everything that we can see in the Trivy system namespace. As you can see, we have several different pods. Now, if I query the namespace again, we still have lots of different pods, okay? So, basically, or we actually don't. They all disappeared. Okay, what happened there? Let's explain that. We have here one main pod, and this is the Trivy Operator pod that's running. This is running the container image for the Trivy Operator. Now, connected to the container image, we have a service, so we can connect to the operator independent of the pods dying and being spun up, right? Because whenever a pod dies and it's spun up again, it has a new IP address. Now, the service allows us to continuously connect to whatever pod is running for the Trivy Operator. Now, the deployment is managing the replica set and the pod for the Trivy Operator. It basically specifies we want to have one replica of the Trivy Operator running within our cluster. So this is everything we have in the Trivy system namespace. Now, what are these? What are these jobs? What are these pods? So these jobs, these Kubernetes jobs, they spin up, they perform one task, and then they are dead. They're removed, they're gone, okay? And basically each job corresponds to one pod, that one's in one pod. Now, each job is a vulnerability scan in this case for one of the containers within my cluster. So if we look in my cluster, we have within this cluster, we have now our Trivy system namespace. As I will just show you, here's our Trivy Operator pod. I can also look at the service. Here's our Trivy Operator service. And then we have a new section called Vulnerability Reports. Vulnerability Reports. Here's one vulnerability report. And as you can see, it's on a Trivy Operator itself. It scans itself in the Trivy system namespace. Now we have lots of different ones. These were all performed by one of the jobs. All of these vulnerability reports were created on one of the jobs. Now, since the vulnerability report has been created, it's now gone. So these all live now within our cluster. So if this is our Kubernetes cluster we have here our Trivy Operator. Let's do it like this. Trivy Operator. And the Trivy Operator performs a scan of one of our deployments. So deployment. It scans it. And once the scan is performed, it creates a vulnerability report. For example, for the vulnerability report. Now, each vulnerability report is connected to the replica set. That's something important to know when you are managing the Trivy Operator and related resources. Each vulnerability report is connected to the replica set within the deployment. Now, the replica set specifies how many instances of your container image is supposed to spin up. So, for example, how many pods are supposed to run a version of your application. Now, if you delete the deployment, you would ultimately delete also the vulnerability report because they are connected. And that makes it easy to keep the cluster clean and not just have random vulnerability reports floating around. So this is ultimately how it works. Now, every 6 hours, Trivy Operator will perform the scan of the container images that are running within your deployments, for example, to see if there are any new security issues that have been found and connected to your container images. And then it will reproduce a new vulnerability report. It will also produce new scans if anything changes within your deployment. So if you make any changes to the deployment, then the Trivy Operator will reperform the scan. Now, this is especially important for any misconfiguration reports. And these misconfiguration reports are called config audit reports. Audit report. So, this is ultimately how it works. Now, the scan is performed through those jobs, through a Kubernetes job. Right, the Kubernetes job performs the scan, and then once the scan is done, the Kubernetes job is removed. Like, it's not longer needed. It's not just hanging around there. This is what we have now. We can look within our cluster also at the config audit reports. And here are all of our misconfiguration reports. As you can see, they are all mainly for the kube system namespace. And if there's anything misconfigured, they are mainly low misconfiguration issues, but also a few high ones within my kube system namespace. Now, remember, this is a local Kubernetes cluster that probably doesn't follow necessarily best practices in terms of installing different Kubernetes components. But depending on these issues, you might want to keep track of them in case you're also running a hosted Kubernetes installation, a managed Kubernetes version. Now, this is our config audit report. We also have infra assessment reports, and these assess the infrastructure of basically the infrastructure related components. As you can see, they're only scanned for our kube system namespace, and they're related to, for example, etcd, that is the local storage within Kubernetes, or the scheduler, or the controller manager, or the API server. And that all relates to the infrastructure of your Kubernetes cluster. Now, you might not be able to scan these components depending on how you run Kubernetes. So then we also have exposed secret reports. And that's really important if you run multiple different applications. If multiple different people also have access to your cluster, you don't want to keep secrets within your cluster just hanging around, let's say. Trivy Operator, and you can find all of the different information on the different reports right here. In addition to the reports I've already shown you, we have infra assessment report, and then RBAC assessment report, and then cluster compliance report. That's how it's called. We can look at the cluster compliance report. And by default, for the cluster compliance report, you should have a CIS report and an NSA report. CIS stands for Center for Internet Security, and NSA is another kind of body of that entity that generates like kind of best practices that should be followed within your infrastructure, within your deployments. And we have pod security standard 2 reports here, a baseline and a restricted. You can also add your own reports for compliance scans to the Trivy Operator. So you can define your own standards, for example, on different requirements that you have within your own company. And then you can check whether your cluster, also your dev environments, are compliant with that. You can check kind of from a central point whether the different developers or cluster admins or SREs who have access to their own cluster or staging environment actually follow best practices there before they move any resources to your production environments. Now, if you're interested in installing the Trivy Operator through other means, through other resources, I'm publishing also a video on the Aqua open source YouTube channel on how you can install the Trivy Operator through ArgoCD, through Terraform, and then I'm also gonna add Pulumi. And let me know in the comments which other kind of resources you would like to see added to the installation guides there. As always, I hope this video is useful. You can find a detailed description as well as all of the commands and server resources in the blog post for this video. The link is down below in the description, so do check that out. Also, it would mean a lot to myself if you could give this video a thumbs up and subscribe to my channel for upcoming videos. The next video will be a detailed introduction, to Kubernetes, Prometheus, Grafana, and how you can set up a Kubernetes Grafana dashboard to visualize GitHub metrics. It's going to be an end-to-end tutorial, a very long form tutorial, so stay tuned for that. I hope you have an amazing day and see you next time. Bye bye.